All right, let's get through this final example. So example at the end here is telling us we've got the height of a ball. It's given by this lovely equation. So f of x equals negative 4.9 x squared plus 9.8x plus 31, or 3.1. X is our time in seconds since the ball was thrown, and then f of x can be our height in meters above the ground. So our question here is asking us how long is the ball above a height of 5.8 meters. So let's just try and imagine what this is going to look like. We've got, some axes, you've got your time and your height. So if we were interested in knowing the initial height or the starting height, we can make x 0. So our starting height or our y-intercept is going to be 3.1. Let's say about here. And then we can assume it's going to go up at some point and then go down. So hopefully we can have this really nice symmetric curve. If we wanted to solve for when it hit the ground, we could totally do that by making our f of x 0. If we wanted to find our vertex, we could do that as well. There's a lot of stuff we could do with this type of problem. For our question though, they're asking us just when is it above, it's asking for how long is it above 5.8 meters. And that's our key here, above 5.8 meters. So 5.8 meters on our graph would be about here. And that kind of makes sense. We're gonna, if this ball starts at 3 meters and it's gonna go up and down, we can assume we're gonna hit it. We're gonna pass a height of 5.8. And it should be, in theory, above 5.8 a few times. So we've got kind of two things to do for this problem. First up is even when is it at 5.8 meters? And then two, we can see, okay, well, if I know these two answers, well, how much time has passed? How much time, or how long is the ball above? So let's start by tackling this first part of the problem here. When is it at a height of 5.8? So we want to take that and use it as our y value. So 5.8 equals negative 4.9 x squared plus 9.8x plus 3.1. And remember, we're always bringing this over first so that we can start with 0. When our 5.8 comes over, it's going to be negative. So this gives us negative 2.7. Now you may want to try quadratic, you may want to attempt factoring, see if maybe you can divide out the 4.9. I think let's just go straight to quadratic formula anyways. So this is going to be my A, my B, and C. You can write it out all if you want first, but I'm feeling lazy, so I'm just going to go right to subbing in. So negative 9.8 plus minus the root of b squared, so the root of 9.8 squared, minus 4 times a, so minus 4 times negative 4.9 times c. And we're using the c value from what we're solving, not the original c value. If we use this as c, we would have found out when it's actually hitting the ground. Remember here we're trying to find it when it's at a certain height. So we've used that height, which means our c value is going to be a little bit different. Okay, now it's up to you how much you want to do in each step. I'd even be okay with you giving me your two x's, but I think I'll start with at least just doing the root part of this. So let me see what I get in my square root. So we've got 9.8 squared minus 4 times negative 4.9 times negative 2.7. So let's see what that gives us. Alright, so I'm getting 43.12 in my root. I'm going to multiply these while I'm at it. Okay. I think let's show one more step of actually what is this root. So root of 43.12, I'm getting a pretty long decimal. Now it's up to you what you actually want to round this to, and it also is going to depend on, you know, are you just doing one step or are you rounding along the way? Or are you doing one step at a time? If you are showing a lot of work at a time, try and use a few more decimals, because that'll just improve the accuracy of your work. But for me in this part I get 6.5, 665, blah 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 blah. I'm just going to round that to, I don't know, 6.57. Usually the question will also tell you how many decimals to round your final answer to, but don't worry about it too much along the way. I'm not very picky. Okay, so this is where we can start thinking about we have to start thinking and paying attention a bit more to a quadratic formula. We know that from here, there isn't really much we can do other than split it up. So our x1 is if we do negative 9.8 plus 6.57. And please add these first. You have to add we have to add what's in the fraction before we can divide. And I'm just going to write out my other option here as well. Let's start here. Negative 9.8 plus 6.57. Then if I divide that by negative 9.8, I'm okay with you just showing me your answer, 0.3295, blah, 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 blah. So about 0.33, let's say there. Okay, and then our x2, let's see what we get. So negative 9.8, this time we're subtracting, and then we're dividing by 9.8. So please just make sure you either add brackets around here or you hit equal sign before you divide. Alright, I just keep missing. Give me one sec here. Alright, now our other answer I'm getting is 1.67. That seems okay. That seems pretty good. So x2, 1.6704 and stuff. So about 1.67. Okay. So let's think about what this means in terms of our graph. These two numbers told us when our ball is at that height. So that tells us the x value of each of these points. So this point is at an x value of 0.33, and this guy is at an x value of 1.67. Okay, so that's our first part. All of this work so far was just for the first part of our equation. Now, what we're actually looking to solve here is how long is the ball above a height of 5.8 meters? Well, I know it first hits a height of 5.8 after 0.33 seconds, and all of this time it's above a height of 5.8. And then it doesn't hit 5.8 again until 1.67. So this entire time, it's above. So for us to answer this question, we're looking to figure out how much time has passed between these. So really, it's pretty simple from here. We just want to subtract. So our time we can get by 1.67 minus 0.33. So our time it's going to take is about 1.34 seconds. So make sure for these word problems you do give me units at the end. And a sentence would be preferred. So it's above 5.8 meters for 1.34 seconds. And if you throw the word approximately in there, even better. So I hope you feel pretty good with the quadratic formula, quadratic equations, and any word problems now. Good luck, guys.